Welcome again, everyone, to day 3 of AWE USA 2023. Yeah, really exciting. I'd like to encourage all of you to download the awe.live app to track our agenda, exhibitors, and connect with other attendees. We have some special events today. Expo Hall is open from 10 till 3. There's the Niantic Lounge, it's open all day, the Great American Ballroom and Foyer. The Snap Lounge is also going to be open all day. Encourage you to visit in the Mission City Foyer. And then lastly, there'll be a wrap-up and Best Showman Awards from 3:45 to 4:15 p.m. in the Mission City Ballroom. Food is also available for purchase at the Hyatt and various other outlets around. Also encourage you to post through social channels and use the event hashtag AWE 2023. Reminder that all sessions will be recorded and will be available for in-person and virtual attendees on the awe.live platform. I'd like to send a special thanks and appreciation to our sponsors. Gold sponsors are Ant Reality, Arbor XR, HoloLight, Lenovo, Sightful, Zapart, and as well to our titanium sponsors, Magic Leap, Niantic, Qualcomm, Snap AR, and XReal. And we got a really exciting presentation for you now on dynamic pixel tuning, the ultimate solution for microdisplays. So let's welcome up Tongtong to the stage to give you the presentation. Welcome aboard, Tongtong.
Thanks so much. Thanks so much for the kind introduction. So obviously, we are a micro-LED company and solution provider for the ecosystem and developers to build devices and products on top of this platform. But obviously, we are very humbled as a small startup, can only do our part, but we are very open and transparent to be able to work with everyone to make micro-LED, make the metaverse and everything more quicker to be realized. So just very quickly, a quick introduction on the company status. So we spun out from Cambridge University in 2020. So we are still fairly young, but we have been progressing very quickly in this particular field and solving the most fundamental problems and issues that are facing the entire industry, mostly on hardware and the light emitting part of the equation. So we have got tons of patent applications from materials to chip designs to driver schemes and all the way to the driving systems. And we are globally positioning ourselves being able to work with everybody across different continents and territories. But our headquarters is in Cambridge in the UK, but we have a strong team, R&D center in Hsinchu in Taiwan, but also a sales office in the US. So basically, our trajectory has been started by thinking and solving the most fundamental, most difficult part of the problem, which is the red color for the display applications. So we were the first one being able to produce native red micro-LED products very early on in 2020, and still maintaining a very strong progression in terms of keep improving the performance and efficiencies, guaranteeing the system level benefits for everyone. But then, obviously, we are able to produce all 3 colors using a single unified material system, indium gallium nitride, that will guarantee the manufacturability and cost reduction potentially for consumer applications, so that you don't have to juggle between different material systems and managing different capex and equipment, etc. But of course, we are differentiating from everybody else is the thing that we are doing for how we can manage all the colors coming from a single LED, so that you don't have to juggle between different subpixels, manage different color conversions, and doing fancy, very complicated manufacturing process flow. So we were winning the best prototype award in last display week in the San Jose by introducing the dynamic pixel tuning technology, where we can tune dynamically as a function of the current density in terms of the color of each LED diode can emit, so that you can have a much better resolution as well as brightness benefits. And then obviously, being a company, we are positioning ourselves as a global design house, as a fabless display company, that we are able to work with everybody along the supply chain. I do mean everybody. So even for equipment manufacturers as well as partners in the display space. The only goal that we are trying to achieve is to try to make sure microLED is winning. And then obviously last week in Display Week, we, as well as this week in AWE, we are announcing and presenting the world's #1 and the first one and the only one, monolithically single panel RGB microdisplay, natively coming from a single LED. That is having a 0.26 inch diagonal of the size of display with 720p resolution that is suitable for all kinds of different applications. And then coming back to why microLED and what we are looking for the display and screens. I'm sure we need more screens, we need more information, but I don't. I'm not sure for myself and for everybody else whether we want the same screens and same form factors and everything. So the point I'm trying to make here is there are a ton of whole new areas of user cases and user environments that we are trying to open up using the microdisplay, microLED-based technology, where we can actually target some personalized functionality-driven applications in each every case. But of course, for each every user case, you obviously don't want to swap your glasses from outdoors to indoor. So our common objective is to achieve a unified all-in-one system that is suitable for all kinds of user cases that you can actually tune and change the form factor, to change the display content on the fly. And then obviously you might have heard microLED. So obviously it's brighter, it's more durable, it's more efficient than the conventional OLED and LCD, of course. But the way that I see microLED is it's a semiconductor device. And it's a semiconductor device that is going to be manufactured in the semiconductor foundry. So it's a semiconductor device working hand in hand, harmoniously with silicon world. So we actually are thinking much beyond the display application. So in a way, microLED, of course, can provide whatever display functionalities and requirements that the system requires us to achieve, of course. But actually, there is a paradigm shift in terms of how how system-level integrators might be using microLED and how to make microLEDs. I'm sure if they have the microLED being manufactured in the silicon foundry, I'm sure they will be still using the silicon mindset to integrate microLED together with the silicon chips together on the same platform. So that is the two angles that I see microLED, why microLED is going to be the ultimate solution. There's no other choice, unfortunately. But of course, we might still have some effort that we need to improve in terms of making microLED much quicker in the market as a commercial product. But as a company and ourselves, in terms of positioning ourselves, we were from day one positioning ourselves in terms of knowing what might be the difficulties and the challenges facing in the industry in terms of the material, chip, fabrication, color, test and repair, inspection, as well as the driving circuitry. So we know all of those very well, and that's what we do as a job in the last decade in terms of knowing the material very well. So because it's an optical device, because it's a semiconductor optic device, that the material will determine the efficiency and the functionality from the beginning, and everything you do will degrade and degrade the performance. So our mindset has been, if it's a material issue, we deal with the material from day one, and then getting to know what the functionality that we need to produce and prepare for the end users. I'm using a semiconductor manufacturing platform. So we're talking about maintaining the performance, but making sure everything is manufacturable in existing capacity and manufacturing process flow, but maintaining the ability to be integrated with the silicon CMOS and other driver circuitries as well. So we are doing 8-inch and 12-inch semi-standard silicon process, and one wafer to wafer bonding that guarantees the highest yield throughput and cost reduction potential for consumer applications. And again, we dynamically tune the colors, so you don't have to juggle and mix all the colors, bring them together, making some dodgy shapes of those pixels. And then you don't need to test them. You don't need to take the wafers and chips offline and test and repair, inspect and replace and put it back on the line and inspect again. So because we have the tunability of the color, so actually we do a demurrer and the calibration together with the tunability that we are launching. So in other words, you don't need to know the LED, the color, before you give it a signal. So when you give it a signal, we will tune the color and the brightness on the fly, as well as calibrating the whole system. And as a company, as I mentioned, we are a global fabless company as a design house. So we have the key processes and materials and designs, and we work directly with OEMs and customers and system integrators, but utilizing existing manufacturing partnerships and semiconductor process that are existing and maybe leftover technology and capacity out there on the market in terms of the manufacturing. But obviously, depending on the market segments and application areas, we provide different products and services and development platforms. We can provide wafers, chips, display panels, modules, and the whole system, depending on obviously how much customization that's needed. So talking back to the fundamental technology that we are able to do this, and why not everybody else can do this, is because we know the material well. We know the good bits and the bad bits and the limitations of this material system. So we are able to produce this porous scan architecture that we can engineer the material properties and functionalities depending on what kind of device application performance that we need to deliver in the end. So actually it's kind of a platform architect of this porous material platform that we are able to change and tune the material properties accordingly, rather than giving a generic platform of material and hoping the best for you guys to do the device. So actually, as you can tell, we can manipulate and configure differently for the material, for different kind of material functionalities, optical, electrical, mechanical, piezoelectric, thermal, all kinds of material properties that we can tune. But of course, thinking about the manufacturability, that's why we are doing 8-inch and 12-inch, because we are doing this porous material, which is a composite of gallium nitride and air. So in a way that we are taking material away from the wafer, so that the wafer will become much flatter. So flatter means much flatter surface for the subsequent processing flows, especially for the bonding process. So that guarantees the highest yield and throughput as well. And then as the first product lineup, so we have all the colors, red, amber, yellow, green. Obviously, we have two greens there. We have apple green and the traffic light green. So the apple green is obviously the most high ice response region, but we are maintaining very high efficiency for that region. Nobody else can do that. But of course, this is the lineup that we are putting for the monochrome. So, and this is the way that how we work with the existing supply chain in terms of we obviously can't change everybody's working sequence and process flow, but we provide the best materials and chips for everybody to complete their side of the product cycle. But we are able to produce all the colors from a single material system. And here is the second generation dynamic pixel tuning technology, where we can emit all the colors. I do mean all the colors, all the visible colors from a single pixel, from a single LED. There's no stacking, there's no processing. One single LED, one single pin junction, one light emitting diode that can emit dynamically all the colors. And as you can see from the color gamut, so conventionally you have only 3 data points, RGB, whether you like it or not. I don't know why that is, but live it. So conventionally, any color that you have to mix between that triangle, that virtual triangle, you have to mix all 3 colors. So for us, actually, we have a feasible and physical true triangle that we can target and cover the entire sRGB, much larger sRGB. And in many cases, actually, you can target yellow directly. You don't have to mix, and you can have the access to cyan and many other colors that don't exist and don't happen to be a color choice for most of the people. But of course, in many ways, we can still use the RGB to be adapted to the existing system integration. But of course, we are in a way presenting an unlimited amount of primary colors for everyone to choose from. And in fact, there are many other colors that may not exist to our knowledge that would be able to give everyone an opportunity to open up the color space. So that's the science, but I don't want to talk too much about basically the material that we're presenting this porous gallium nitride template is basically improving the material quality so that we have the best efficiency and quality of the material for the single color. And for the single colors, for the benefits of many people here might still be interested in the efficiencies and brightness and everything. So we have the outperforming display level, chip level performance. So for the 30 micron test platform, we have larger than 10% external quantum efficient or wall plug efficiency for the red, and more than 30% for the green, and more than 60% for the blue. So whichever way you look at it, for display applications, you are in good hands in terms of having the best platform for building devices, even for larger display form factors. And for the display level, panel level, we have 0.26, 720p, 3.5 micron, more than 5,600 ppi display panels level brightness measurements here. So we have more than 700K nits for the red color, and then more than almost 3 million nits for the green, and then again more than 1 million nits for the blue. So whichever way you may wish to have our devices integrated, you have the best brightness and the efficiency, ensuring the power consumption. And then obviously, why we are using this single material system is because for display applications, you wish to have all the colors being driven at the same current density with the same electrical characteristics. And that's the major reason why we use this native indium gallium nitride red, because all the blue and green colors, you are using the same material. So by definition, all the optical and electrical characteristics are the same, rather than comparing to the other material system where you have to drive it 100 amp or 1,000 amp. Basically, I'd only say this, you're hitting the display as a brick. Nobody knows what's going to happen after a few minutes or whatever. And then obviously, talking about coming to the science, so physics is the same. We are not turning and reinventing the physics, but in terms of how we can realize the physics that we're supposed to be having is the materials, how we can engineer the material in terms of exploiting this quantum Stark effect, in terms of how we can shift the wavelengths, basically. And the ability to play around and manipulate this quantum confined Stark effect, effectively having all the wavelengths being covered from one single LED, is the ability to grow more flexible, more aggressive LED designs on top of our platform. So basically, we have a linear relationship as a function of the current density and the wavelengths. Obviously, this is a piece of old data that we had last year, but now we can actually achieve 200 nanometer from 450 nanometer to 650 nanometer within 2 orders of magnitude of the current density. So now I actually don't care whether there are uncertainties and variations in the epitaxy, chip processing, or whatever. I can always tune it back. That's what I mean by you don't need to test and repair. I always can do the calibration in the display calibration stage. And then obviously this slide, no offense to other people doing other approaches, but this is how we can differentiate ourselves. So people doing quantum dot color conversions, fine. That's probably the easiest thing to achieve full colors, but reliability and lifetime may be a problem, especially looking for very high brightness and high efficiencies. And people are thinking about stacking different LEDs one on top of another. In conventional silicon world, you can stack 60 layers, but in compound semiconductor, because the gallium nitride is not grown natively, you have to get rid of the silicon or sapphire and planarize a little bit and guarantee the smoothness before you do the stacking. And you can imagine how many electrical contacts you have to make in terms of driving every LED dial. And of course, some other people doing selective area epitaxy, hoping the nanowires can have the different colors, but of course, coming down to the manufacturability, no one can guarantee all the millions of nanowires are having the same optical and electrical characteristics. But for us, actually, as I mentioned again, one LED gives all the colors, and that is happening on the semiconductor platform for the manufacturing. And of course, the benefits for doing this dynamic pixel tuning is you don't need subpixels. Again, you don't need to know every color of the LED before you drive it, before you give it a signal. So for the same PPI or the resolution that we require, we can have much larger pixels or emitting areas. So the brightness and efficient benefits are humongous. And of course, talking about the manufacturability, we don't need different mass transfer technologies. You just need one transfer process. And then talking about the small form factors that may require, but maybe more relevant for the audience here, is the AR applications where people keep chasing on high resolutions, high brightness, and everything, because we're eliminating the subpixel by definition, on the mathematics, we are 3 times, 4 times higher the PPI, and even for the same display size. And again, we are manufacturable using a semiconductor platform that guarantees the cost benefits for everyone to make your product. So here are some demonstrations in terms of arrays of micro-LEDs where we can change the current density input and tune the color dynamically. Of course, there are many different driving schemes and driving methods that we can utilize to make up different colors. But as I mentioned, you only need 2 signals to make a white point. That's a system-level simplification that we are introducing. And of course, this is the 0.26 diagonal 720p full color single panel natively. You have all the colors from there. So I'm not sure, but to our knowledge, this is the world's only one 720p full color microdisplay. So we are presenting this as a development platform for everyone to hook up with the waveguides and light engines and the end user applications to have some sense so that we can build and define the products together. And then talking about colors. So conventionally, as I mentioned, you only have 3 data points for the color. But 2D-dimensional color map may not be a good representation in terms of how much benefits we are getting. But if you look at the 3-dimensional representation, where our color space, because of the tunability, we can have a much more symmetrical and much more coverage in terms of how many colors. But of course, depending on how the video piping, how the display signals are being implemented, we can have 3 RGBs and 4 primary colors or 6 primary colors, depending on how the SoC level support that we can get from Qualcomm. And then here's a brief list of the availability of different kind of products. We have different sizes for different applications for 0.55 inch and 0.39 inch that are more suitable for head-up displays. We are having availabilities on single colors and full colors as well. For 0.26 and 0.12, we also have single colors, not just RGB, any color that you wish to have in the visible range for different applications and reasons, but also the full color, particularly on the 0.26 inch as an evaluation kit that we are open and happy to share with everyone to build products and customization and defining the functionalities. And of course, if you really want to achieve the smallest form factor, we do also have the 0.12 micro-LED microdisplay as well. For now, we have the evaluation kits for the single color, but the dynamic pixel tuning full color will be coming very shortly in the next 2 months. So obviously, that's a rather small portion of what we do. This is a rather wide and comprehensive list of different products and services that we can work with everybody. For the small form factors, AR and head-up display near applications, we have different products and evaluation kits, but also for larger displays, for smart wearables and smart flexibles and transparent displays. Essentially, we are a true believer of micro-LED can really open up a wide range of different applications that nobody can even think of using displays or informations and in all kinds of different areas. But for us, actually, we're focusing on 3 major user cases. So productivity improvements, home, and transportation, which is basically associated with the automotive. And finally, I would like to share one vision that we have. So as I mentioned again, it's a semiconductor device where every single pixel can be controlled and independently driven. So every single pixel should be a display where we can have all the colors. But of course, once you have millions of semiconductor pixels on a CMOS platform, that is the perfect opportunity where we have finally achieved the photonics that can talk and being implemented with the electronics. So that would be the last sort of vision that I would like to share with everybody. If you really think micro-LED is just a display, you are wrong. Micro-LED is far beyond than a display. It can be a display, it can be a computer. So thanks so much for attention.
Thanks again, Tongtong. Let's hear another round of applause for Tongtong.